Hi, my name is Erica Dobbs. My project on equine gait analysis uses kinetics and kinematics to increase the efficacy of diagnosing multiple limb lameness in horses compared to a traditional subjective lameness exam. One of the major problems with a traditional subjective lameness exam is that it relies on human evaluation of the horse's asymmetries, which is prone to bias and error. In fact, agreement between experienced lameness clinicians is reported to be around 60%. By using objective methods, we have data points that we are able to compare to reference intervals or between a horse over time. For objective gait analysis, the primary gap in knowledge in the field was in clinical interventions. This includes the impact of medication and analgesics on kinetics and kinematics. In my study, a population of horses with naturally occurring lameness was used to simulate clinical cases. This was done in order to apply the research technology to the clinical setting in the future. The methods used in this study were kinetics, kinematics, and the subjective evaluation. Since subjective evaluation is the current clinical standard, this was included in order to retrospectively compare the objective methods to the subjective evaluation to determine how we could improve our clinical lameness exam. Kinetics uses the measurement of forces, in this case applied to the hoof of the horse. Kinematics looks at movement of the body through space over time. This measures variables like position, velocity, and acceleration. We can measure kinetics and kinematics in both the walk and trot. For the walk, it is a slower gait, so we can look at the distribution of forces over time during the stance phase or when the horse's foot is on the ground. For kinematics, we look at the angle of maximum fetlock extension at the mid-stance phase. At the trot, it's a faster gait, so we look at one maximal force at the trot on the force plate. For kinematics, there's an inertial sensor system that's commercially available called the lameness locator, and this is used to measure the vertical displacement of the head and pelvis of the horse during the trot, which are the variables that are used in the subjective lameness evaluation to determine which leg is lame. Our research is ongoing, but some of our preliminary findings include the following. We found agreement in most cases between subjective and objective analysis at the trot. Both kinetic and kinematic methods identified a multiple limb lameness where only one forelimb and one hind limb were lame in combination. However, with the force plate at the walk, we were able to identify additional multiple limb lamenesses, including bilateral fore and hind lamenesses when compared to the trot. This is important because the subjective and objective methods at the trot often rely on asymmetries between the forelimb and the hind limb to identify the lameness. So using the force plate at the walk could help us further in the clinical exam. This research is ongoing, but the eventual goal is to be able to transition these technologies into the clinical setting to improve our evaluation of lameness in horses.